Welcome to the channel. So today's topic is ExtraTreesClassifier. This is another ensemble learning method which fits a number of randomized decision trees on various subsamples of the dataset. So this particular working principle of this algorithm helps us to reduce the variance of the model, which in turn helps us reduce the overfitting. So let's get started and see how we can implement this machine learning algorithm using Scikit-Learn. So as usual, let's import required libraries. So import pandas as PD. Matplotlib, then import from sklearn. Import train test split. Then from sklearn .ensemble import ExtraTreesClassifier. Then from sklearn.tree import plot tree, and finally we need matrix from sklearn. Okay, so these are the required libraries. Now we need to load the dataset. So I will use ionosphere dataset for this example. So pd.read csv, ionosphere.csv. Let's check the first few rows. Okay, so this is our dataset. We can see the columns are written using the attribute 1, 2, 3, 4 all the way up to 34. These are the features, and last one is the target column. Okay, so I can only say 1 and 0 in the first two columns. Let's check the unique values of these two columns. Okay, so column 1 has 2 unique values, so this is okay. And let's check the second one. Okay, but column 2 only has 1 value, which is 0. So I do not want to use this one. So I will drop this feature before fitting these features into the model. Okay, so and also we can now check the unique values of the target column. So let's first check the shape. So we have 35 columns and 351 rows, and if we check the unique entities of our target column, so we will see two. One is G, another one is P. Yes, so we can see GP both here. And also let's check the value counts. Okay, so G is present 225 times and P is present 126 times in this data set. So G and B means good and bad. These are good and bad radars in this data set. Okay, so now we can perform some pre-processing. So So we'll change these categorical values with numerical values. So apply lambda so 0 if B, which means bad reader, else it will be 1. Let's check the first few rows again. Okay, so now we can see 1 and 0 instead of G and B. We can just confirm these as well. So this will result in 1 and 0. Again, this will also result in 1 and 0. Okay. So now what we can do, we can separate the features and the classes. So I want to drop the attribute true, attribute to column, this one, because this only contains 0, nothing else other than 0. And also I want to drop the class column, which is the target, and x is equal to 1 and y. So I'm only selecting the last column for y. Okay, now we can split the data set. So xtrain, xtest, ytrain, ytest. So 25% data will be used for test and 75% for train. Let's check the length of the train and test set. Okay, so we have 263 samples in the train set and 88 in the test set. So now we can train our model, which is ExtraTreesClassifier. So let's just call it etc. Okay, so we have which parameters, n estimators, max depth, mean samples, etc. Okay, so let's just change these to n estimators and max depth. So these are the number of trees, so let's use 10, and max depth let's say 5, and random is at 42. So etc.fit xtrain and ytrain. Okay, so the model has been trained. Let's check both the training and test accuracy. So accuracy on the train set, and accuracy on the test set. Okay, Okay, so both accuracies are over 93%. Train accuracy is slightly higher than the test accuracy. Okay, so this is a good outcome. So let's plot confusion matrix. So I predict etc.predict xtest. So ytest and ypred. Okay, so now we can just use matplotlib. So let's just add the labels in the axis. So x labels will be prediction, font size 15, and this will be bold. Okay, so now this will be y label. This is our ground truth. Okay, so this will be y ticks. So this is how our confusion matrix looks like. Okay, so the model predicted 1 correctly in the test set. There is no wrong prediction here, but in case of 0 we have 6 wrong predictions. Okay, so 0 and 1 means B and G, bad and good radar. So we can also see the confusion matrix by using the categorical labels. Before that we can also confirm the y-test value counts. So you can see 1 is present 56 times and 0 is present 32 times. 26 times prediction have been correct. So now let's just B and G, and here we can just use categorical labels. So now instead of 0 and 1 in the axis we have B and G. Okay, let's also check the F1 score. Sorry, matrix. So y-test, ypred. And also check the checkered score. Okay, so this is how 𝐴1 score and 𝗁𝗫𝐻𝐵 score looks like. Let's now print classification report. So plt.figure fig size 3020. And use the plot tree function. So we have 10 trees because I selected n estimators is equal to 10. So let's visualize the last one. Font size will be 25, field true. Feature names will be x.columns because x is our features, and class names, let's just copy this. Okay, so and plt dot type layout. Okay, so this is the last tree, and you can see based on this condition attribute 32 less than or equal to 0.929, it splits the samples and it starts with 94, 169. So if we check y train dot value counts, so we have 0 present 94 times and 1 present 169 times. So this is the initial data. From here, based on these conditions, it forms a tree. Okay, so I think only one final step remains. Oh sorry, I made a mistake. So forgot to print the classification report. This will be y-test, y-bread. Okay, so this is what the classification report looks like. So we can see the precision recall F1 score for individual class and also see the accuracy here. And this is actually let's call it plotted tree. Okay. Now finally we can also show the feature importance. etc dot feature importances index will be etc dot feature names in columns importance. So now this appears as a data frame with some value for each feature that we have used. Okay, so now we can just show it as a plot. So if I dot sort values, importance, and plot. It will be horizontal bar plot. 𝐸𝐶𝐻7,7. Title will be feature importance. Okay, something is wrong. Also, this is kind. Okay, now we got our plot. So the most important feature is the attribute 1, which is the first column. So this is apparently the most important feature. Then we can see feature 6, 7, etc, etc. Okay, so this legend is very close to the values. Let's change the location. Okay, so now I have moved it to the right side from the left side. Okay, so this is how we can implement ExtraTreesClassifier, which is an ensemble learning method using Scikit-Learn. So that's the end of this video. Thanks for watching.